All right, so chemistry. Again, we're going to start off easy and you're going to get the harder questions at the end. So first questions about structure and bonding. What type of bonding is present in calcium oxide? What do you guys think? So this is in the bondings topic. It's either going to be ionic, covalent, or metallic. What are these things here? These are ions. There, I've got a similar diagram here. This is ionic bonding. So in ionic bonding, you've got oppositely charged ions, you've got positively charged ions, you've got negatively charged ions. They're attracted to each other with electrostatic attraction. Next question. Figure 2 shows a particle of methane. So anytime this shows charges, would it be ionic bonding? Let me think about that. No, because, I'll show you another one. Metallic bonding also has ions. Look here. That's what metallic bonding looks like. It's got positive charges here. It's a positive metal ion surrounded by C of D localized electrons. So that would not be ionic. You can say it's always ionic when you have positive charges and negative charges, but not when you just have positive. So for metallic, you would have positive metal ions surrounded by electrons, C of D localized electrons, whereas in ionic, you'd have positive ions and negative ions. You don't have free moving electrons. That's the difference. Good question. Make sense? What type of... Yep, okay, good. What type of particle is present in figure 2? What type of particle? So you've got ionic compounds, you've got covalent compounds. How can you differentiate between ionic and covalent? Ionic occurs between a metal and a non-metal. Covalent is between a non-metal and a non-metal. And then you got metallic, which is between a metal and a metal. So here we've got carbon and hydrogen. So what's that? What's carbon in the periodic table? What's hydrogen in the periodic table? Let's get the periodic table up. Over here, we've got metals, non-metals. So everything to the right of this dotted line is a non-metal. We got carbon here. Hydrogen should be to the right, even though it's over there. It doesn't count as a metal, even though it's in the metal section, because it should technically be here. Hydrogen is a non-metal. They're both non-metals, so what we're dealing with here is covalent. So, yeah, it is covalent. Well done. So within covalent, we've got three different types of compounds. You can have simple molecular substances, giant covalent substances, and polymers. This here is a simple molecular substance. It's basically small molecules. That is a molecule of methane. A molecule is basically more than one atom bonded together in a particle. Next question. Figure 3 shows a structure of C60. This is known as Buckminster fullerene. Funny name. That's all under this topic, allotropes of carbon. So we got 4 different types of allotropes you need to know. So you need to know diamond, graphite, graphene, and then fullerenes. And within fullerenes, there's 2. There's carbon nanotubes, and this is the one I was talking about. It's the one that looks like a football, Buckminster fullerene. These are all giant covalent structures. That's not one of the options here, though. It's not diatomic. What does diatomic mean? Diatomic means when it exists as two molecules. So that would be like H2, Cl2, N2, O2. It's not ionic because this is just carbon. Remember, for ionic, you need a metal and a non-metal. So it's not diatomic. It's not ionic. It's not metallic either because carbon is not a metal. It's a fullerene. Remember, there's two types of fullerenes, this one and nanotubes. Next one, we got a structure of graphite. What type of bond is labeled here? What do you guys think? In graphite, what is this? What are the straight lines here? Each of these dots there, carbon atoms. But the lines in between them, they're a bond. So this also comes under covalent bonds because remember, these are all non-metals. You've got carbons, which are non-metals, bonded to other non-metals, more carbons. It's going to be covalent. Everyone's quiet. Is it because this is more difficult? In graphite, each carbon atom forms bonds with other carbon atoms, shown in figure 4. How many electrons does one carbon atom use to form one bond? Okay, so first of all, you want to figure out how many electrons around carbon. So carbon, if you look in the periodic table, it's in group 4. Carbon is in group 4. That means it's got 4 electrons in its outer shell. That means it can form 4 other bonds. But that's not what the question is asking. So 4 other covalent bonds. So carbon, 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 carbon. But in graphite, look here, one carbon atom is only bonded to 3 other carbon atoms. So that means one of these are not bonded. So you got 1 electron free here. That's the reason why graphite conducts electricity, because of that spare electron. That spare electron can basically flow through the graphite. But that's not what the question is asking. The question is saying, how many electrons does one carbon atom use to form one bond? People would think it's 3, but it's not. It's asking for just one bond. This is one bond. This is one bond. This is one bond. So the carbon atom only needs 1 electron to form one bond. It's a trick question. Next question. So this is electrolysis. Not really electrolysis, actually. I think it turns into electrolysis. Yeah, later. An electric current is passed through copper. Figure 5 shows that copper conducts electricity as a... So copper right now, you can clearly see there, it's not a gas, it's not a liquid, it's not a solution, it's solid. Must be solid. Copper conducts electricity because the movement of delocalized... Okay. Why do things conduct electricity? In the whole of chemistry, I think you learn 3 different things that conduct electricity. We've got metals. We've got ionic compounds. But they only do that when they're molten or aqueous. And you've also got graphite. Those are the only 3 things that you'll learn. They have different reasons why they conduct electricity. Metals conduct electricity because of delocalized electrons. That's the answer to the question. Ionic compounds, they do not have delocalized electrons. Loads of people make a mistake here. They don't have delocalized electrons. They have free-moving ions or delocalized ions. You don't really say delocalized. You say free-moving ions. For something to conduct electricity, you need something that's charged. You need a charged particle, and that charged particle needs to be free to move. So in metals, it's electrons that are free to move. But in ionic compounds, remember this, it's ions that are free to move. And they only do so when they're molten or aqueous. So when they're melted to a liquid or dissolved in solution. If they're solid, they don't conduct electricity because the ions are not free to move. And then for graphite, it's the same as metals. They have delocalized electrons. And that's the same reason that I explained above here, is because this here is a delocalized electron. So question, the answer is electrons. Next question. Figure 6 shows apparatus used to investigate the effect of electricity on sodium chloride solution. Sodium chloride conducts electricity when, okay, this is what I just explained. Sodium chloride. Sodium is a metal. Chloride, chlorine is a non-metal. So what type of bonding are we talking about here? You've got a metal and a non-metal. I've got it up here somewhere, right? Yep, here. Metal and non-metal means it is ionic. And what did I say about ionic compounds? I said it here. They conduct electricity when they're molten or aqueous. So this one conducts electricity when, in the question, it says it's a sodium chloride solution. Solution basically means it's dissolved in water. The answer is dissolved. No, so molten and aqueous are different things. You can't put molten here. Molten is when it's melted into a liquid. So you literally heat it up to its melting point and it turns into a liquid. Aqueous means it's dissolved in water. So like salt, for example, salt is ionic, like just table salt that you use in cooking. That's ionic. You can dissolve it in water to make salty water. That's aqueous. Or you can heat it up to a very high temperature. It's got a very high melting point. So I don't know what it is, but it's when you melt that, that's called molten. That's the difference between the two. So for this one, because they've used the word solution here, it means the answer is dissolved. Sodium chloride is made up of ions. Figure 7 shows the apparatus to investigate the effect of electricity on solid sodium chloride and molten sodium chloride. Okay, so this one. Okay, that's good. So solid sodium chloride, the filament bulb does not light up, but in molten sodium chloride, it does. That's because in solid sodium chloride, it does not conduct electricity, but in molten, it does. So this is literally what I've just explained. What do you guys think the answer is here? Let's see if you guys have been listening to me. Solid sodium chloride does not conduct electricity. Why? And why does molten sodium chloride conduct electricity? That's not an option. Delocalized electrons. It's one of these. This is what I said here. So ionic compounds that are molten. Yep, good. So solid sodium chloride does not conduct electricity because the ions are fixed. Molten sodium chloride does conduct electricity because the ions are free to move, mobile. Not that, not that. That's not why they conduct electricity. Well done, guys. Okay, next question. It's about acids and bases. Which ion is found in all acids? What do you guys think? Here's some examples of acids. We got hydrochloric acid. We got nitric acid. We got sulfuric acid. What's common in all of these? The ions are mobile in molten. Yeah. Does that not make sense? So when it's molten or aqueous, the ions are mobile. They're free to move. But when they're solid, they're not free to move. They're fixed. Yeah? Okay, good. All right, so what's common in all of these? They all have H's. Oh, okay. If you're behind, I think you can just leave it, leave the class and come back, and then you might come back ahead. Next question: zinc nitrate can be produced by reacting an acid and a metal oxide. Name the acid and metal oxide used to produce zinc nitrate. What do you guys think? How can we produce zinc nitrate? Let me get the notes up. What acid would we need to form a nitrate? Yeah, nitric acid. Not that behind then. Yep, well done, Hanya. So here, we've got a table here that tells you to form a nitrate, you need nitric acid. And then the metal oxide, it specifically says oxide, so it's going to be zinc. You need zinc in there, so it's going to be zinc oxide. In an equation, zinc nitrate is written as ZnNO32. What does AQ mean? AQ means it's aqueous. Aqueous means it's in solution. Solution means it's dissolved in water. Ooh, did not spell that properly. Aqueous. Ignore. Aqueous. The pH of a solution is 8. Some hydrochloric acid is added to the solution. So just the pH after mixing. Okay, so you've got something with pH of 8. You add an acid. What do you guys think will happen to the pH? There's a lot of numbers that you can say here to get the right answer. pH 8, you add an acid. 4, yep, 4 is acceptable. Anything under 8 is acceptable. Yeah. Because what you're doing is you're adding an acid. Remember, acids have a low pHs. So if you add an acid to a solution, its pH just decreases. Table 1 shows the solubility of these 3 solids at room temperature. So you can see here, this one is very soluble because the mass of the solid that dissolves is very high. 100 grams dissolves. Here, 50 grams dissolves. Silicon dioxide, 0 grams dissolves. So that's completely insoluble. None of it dissolves in water. The teacher labeled these 3 solids A, B, and C. She gave the student information showed in table 2. So what they've done here, they've added water to it, and then they've measured the pH. Describe a method that could be used to identify these 3 solids A, B, and C. So what's this step here? What has the student done here? It's literally told you. And how has the student got these? So yeah, the first part, observation when added to water. So literally the first step here is they've added water. So they've added the solid to water. Someone said decrease. I can't see your name. Can you just change your username to your name, because I'm not sure who you are. You said decrease. I'm not sure what you mean by that. Which question are you talking about? So yeah, you add the solid to the water. That's the first step. That's what they've done here. Second step, they've found the pH. How could they have found the pH? What do you think that step is? How would they have found the pH? How do you find the pH of a solution? You add something. Or you can use a piece of equipment. Yeah, you could say pH probe. You can use universal indicator. Yep. Any one of those is acceptable. Add universal indicator, pH probe. Litmus paper. Litmus paper won't tell you the pH though. Litmus paper, litmus solution could, but litmus paper would just turn one color, isn't it? So it won't tell you that you have a pH of 14, 2, or 7. So I don't think that would get you the mark. But universal indicator and pH probe, you can kind of tell the pH from that. So that's, how many marks is that? That is 2, I'd say 2 out of the 4 marks. And then what can you say about all of these? So for example, solid A, what is solid A? It's the one that's got a pH of 14. Out of these 3 things, which one would have a pH of 14? pH of 14 means it's alkali. What type of compounds are alkali? So think about what alkalis release. Alkalis always release OH minus, isn't it? So hydroxide. Yeah, exactly. So the hydroxide here, this must be solid A. So you can say A is sodium hydroxide. A sodium hydroxide. Now we have to identify the other 2. What else can you say here? This one does not dissolve. Only one of them do not dissolve in water. Remember I told you. Here, 0 grams of silicon dioxide dissolves in water. So that must mean that is C, because C does not dissolve. So C is silicon dioxide. And that leaves us with B as phosphorus oxide. Okay. Next, we've got a periodic table. Question about sodium and chlorine. Figure 1 shows the position of sodium chlorine in the periodic table. So we can see here, this is group 1. This is group 7. One difference and one similarity in the electronic structure of sodium and chlorine. So you can tell that from the group. The group 1 and group 7, what does that tell you? That's a difference between the 2. Sodium has 1 outer electron. But chlorine has 7. So that's one thing you can say. What's the similarity? Can you guys tell? It's to do with the period number. Period 1, period 2. Sodium and chlorine are both in period 3. So what's the similarity here? No? So in the periodic table, same row meaning they have the same number of yeah, good. They both have the same number of electron shells. 3 rings around their outer 3 rings on their outer shell. Not 3 rings on their outer shell. They have 3 shells. They have 3 shells. So they both look like this. So this will be the nucleus. 1 ring, 2 ring, 3 ring. So they both have 3 electron shells. Got it here. So the group number tells you the number of electrons. The period number tells you the number of shells. So similarity is they both have 3 shells. Sodium atoms react with chlorine atoms to produce sodium chloride. Describe what happens when a sodium atom reacts with a chlorine atom. Right. What type of bonding is in sodium chloride based on what I've said, guys? Sodium and chlorine. Look at the position. Figure out which one's metal, which one's non-metal. Is it covalent? Is it ionic? Or is it metallic? Ionic. Yep. Well done, Nav. Ionic. So this is a question about ionic bonding. So let me draw the two. We've got sodium. I'm just going to draw the outer shell. Sodium is in group 1. So it's got 1 electron in its outer shell. Chlorine is in group 7. So it's got 7 electrons on its outer shell. What's going on? Okay. They both want to gain a full outer shell. That's what makes them stable. So the best way for that to happen is sodium gives one of its electrons to chlorine. That way sodium has a full outer shell, chlorine has a full outer shell. You basically need to describe that in words to get your 4 marks. It says write about electron transfer. So you get 1 mark for saying sodium loses 1 electron. Then chlorine gains 1 electron. That is actually all 4 marks. Sodium loses, I'll tell you what the marks are. Sodium loses is 1 mark, 1 electron is 2 marks, chlorine gains 3 marks, 1 electron, 4 marks. But if you wanted to give more information, sometimes they expect you to explain what happens after this. When sodium loses 1 mark, it forms a sodium plus ion. When chlorine gains 1 electron, it forms a Cl minus ion. Does that make sense? Tell me if you want me to re-explain everything. This reaction here is exothermic. Complete the reaction profile. So let me go into my notes and let me go to reaction profiles. So that comes under energy. So remember, guys, you can just search at the top if you're not sure what topic something comes into. Energy changes, reaction profiles. So it says it's exothermic. Here are the 2 types of reaction profiles you can have. Exothermic, endothermic. Exothermic one, you can see it goes from a high level to a low level. So your products need to be lower than your reactants. So when you draw this, make sure your products are down here. And then in between, we have a hump like that. Does it say to label anything? Sometimes you need to label the activation energy, but it doesn't ask us to do that. This is just 2 marks, 1 mark to show the lower level and the second mark to show the curve. Sometimes you need to also label the activation energy. That'll be that. But you don't need to for this question. And sometimes, let me just do a dotted line there. Sometimes you need to label the energy change. Which is basically from the reactants directly to the product. All right, question 4. Write the state symbols for chlorine at room temperature. What do you guys think? What is chlorine at room temperature? What state is it at? I'll get the topic up. What do you guys think? It's in group 7, isn't it? So you need to know the properties of all the group 7 elements. No one sure? Here we go. So we've got fluorine, chlorine, bromine, iodine. Fluorine and chlorine are both gas. Bromine is liquid and iodine is solid. So the answer for this one is gas. Yep. And it says write the state symbol. So you don't write gas. If you write gas, you don't get the mark. You have to write G for gas. Next one is about covalent bonding. Remember, covalent bonding is between 2 nonmetals. We've got fluorine and fluorine, both nonmetals. Complete the dot and cross diagram to show only outer shell electrons. Remember, they both need to have a full outer shell. So they both need to share it to get full outer shell. So first thing to figure out is how many electrons on the outer shell of fluorine. So we can use our periodic table here. Look for fluorine. You can see here it's in group 7. That means it's got 7 electrons. So this fluorine has 7 electrons. So we'll say 7 crosses. 1, 2, 3, 4, 5, 6, 7. We've already drawn one up here though. So I'm not going to draw that one. We got 7 dots or circles. 1, 2, 3, 4, 5, 6. So to get a full outer shell, they don't want 7. They both want 8 electrons. So this fluorine wants 8. This fluorine wants 8. So for this fluorine to get a full outer shell, it needs to basically share one of these electrons. So let's share this one. I'm going to get rid of that. I'm going to put that in the middle. The right-hand side atom wants one of these crosses. So I'm going to put that one in the middle. So they're both sharing 1 electron each. And now you can put the remaining. So we've got 4 crosses here. So 1, 2, 3, 4. Let me start again. Right, let me start again. I am confusing myself. 7 electrons, 7 electrons here. Okay, so we've taken one and we've put it in the middle. So we've taken that one, we've taken that one, put it in the middle. We have 2, 3, 4, 5. Yeah, so we've taken one. We've got 6 left here. We've got 6 left here. So we need to draw all 6 here. We've got 1 cross here already. So the 1, 2, 3, 4, 5, 6. That covers all 6 here. And then we've got 6 circles here. 1, 2, 3, 4, 5, 6. Don't know why I complicated that. But yeah, that's how it looks like. Next question. A fluorine atom can be represented as this. What is the total number of electrons in a fluorine molecule? What do you guys think the answer is here? I want you guys to fall into the trap. So top one is mass number. Bottom number is atomic number. What is the total number of electrons? $18. Yep, answer's 18. There's 9 from each one. Because it's F2, you got to times it by 2. Do not write 9. That's only one atom will have 9 electrons in it. Next question. Aluminium reacts with bromine to produce aluminium bromide. Complete the balanced chemical equation for this reaction. Aluminium bromide. So if we look at our periodic table, aluminium is in group 3. That means it has a charge of +3. Bromine or bromide is in group 7. Group 7 means it has a charge of -. To work out the formula for aluminium bromide, you swap these two numbers around. So the 1 comes to the Al, the 3 goes to the Br, and you end up with AlBr3. The swap and drop method. So know how to do that just for working out the formula of compounds. So this is AlBr3. And now what we need to do is balance it. What numbers do you think we need to balance this? We've got 2 aluminiums here. So we need 2 aluminiums here. We've got 1, 2, 3 bromides. Bromines times by 2. Remember, there's a 2 here. So there's 6 bromines here. That means we need 6 bromines on the left-hand side. There's 2 here. So you're going to need 3 because 3 times 2 is 6. Because you need a total of 6 bromines. The answer is going to be that. Hope that makes sense. Okay, next we've got a 3 marker. When chlorine reacts with potassium bromide, chlorine displaces bromine. This is a displacement reaction. So you can see here, chlorine displaces bromine. The reason why is because chlorine is more reactive than bromine, so it replaces it in the compound. Question is asking, why is chlorine more reactive than bromine? So that is all to do with how big the atoms are. So here we've got an explanation here. Okay, so in the notes we're looking at fluorine and chlorine. Yeah, well done, Nav. Electron is further from the nucleus in bromine. So here we're looking at fluorine and chlorine in the notes, but in the question we're talking about chlorine and bromine. So chlorine is the bigger one. Sorry, chlorine is the smaller one. Bromine is the bigger one. Okay, so that means in bromine, the electron is further away from the nucleus, which means there's less attraction from the nucleus. If there's less attraction from the nucleus, it's less likely to accept an electron, to gain an electron, which means it is less reactive. So to get all 3 marks, first one is to say chlorine is smaller. So you can say chlorine, so that's the smaller one. Chlorine has greater attraction. Yeah, or you could talk about bromine. You could say bromine is bigger. Bromine has less attraction. That means chlorine can gain electrons more easily. Does that make sense? Let me know if you want me to re-explain that. Okay, nearly done. Gotta make sure I get through all of these, because after 2 hours my live just automatically ends. I can only do this for 2 hours, otherwise that's the maximum amount of time, otherwise we'll just shut off. So let me try and get through everything in 15 minutes. This question is about diamond. Why does diamond have a high melting point? So I've already explained this. This is giant covalent structure. So that means it has a large network of covalent bonds. Covalent bonds are very strong. So out of all the 3 bonds that we learn, ionic, covalent, and metallic, covalent is the strongest. So that means you need a lot of energy to overcome it, which means the melting point is higher. So 1 mark to say it is a giant covalent structure. Covalent bonds are strong and need a lot of energy to overcome or to break. Oh, yeah, that's all 3 marks. 1, 2, 3. 3 marks done. Next. Explain the conditions needed for sodium chloride to conduct electricity. Okay, we've done this already. Who remembers? What do you need to do to sodium chloride for it to conduct electricity? Sodium is a metal, chlorine is a non-metal. Who remembers? We did it about half an hour ago, 20 minutes ago. Everyone forgotten already? Yes. Molten or aqueous. Remember, we got it here. Has to be molten or aqueous. Not electrons are delocalized. Remember, for ionic, don't say electrons, say ions. So the ions are free to move. So a very common mistake. If you say electrons are delocalized, that's only for metals and for graphite. Yep. So for 3 marks here, would say it needs to be molten or aqueous. That's 1 mark each, actually. You get 1 mark for this, 1 mark for that. 3rd mark, so that ions are free to move and carry a charge. Yeah, well done. Okay, now we've got what type of bonding do we have here? Sodium. Sodium is a metal. we have metallic bonding. So remember, someone asked, if there's an ion, does it always mean it's ionic bonding? No, it doesn't. Here, it's not ionic bonding. This is metallic bonding. We have positive ions surrounded by a sea of delocalized electrons. And that's why this conducts electricity, because of the delocalized electrons. This is not asking about why does it conduct electricity. It's asking why does it conduct heat? Why does it conduct thermal energy? The answer is exactly the same. You can say the delocalized electrons. So it has delocalized electrons. That are free to move. So that means it can transfer energy through its structure. It can transfer thermal energy through its structure. If it was asking about electricity, say it can transfer a charge, but this one is transfer energy. So don't get put off by the number of lines. Look at how many lines there are here. They've given you so many. People would think you have to write like an essay here. It's only 3 marks. You can get away. I wrote quite big as well. You can get away with writing this whole answer in 2 points and getting 4 marks. So just so that you don't waste time in exams, just keep it concise. Just get straight to the point. Don't write like an essay. Write bullet points. You can still get marks with bullet points. That's the best way to do it. Just try and get through the paper and just get the main points across. Right, how much do we have left? Okay, nearly done, nearly done. We've got some calculations, some more calculations. Iron reacts with dilute hydrochloric acid to produce iron chloride solution and one other product. What's the other product? What do you guys think? Let me get it up in the notes. So this is reactions of acids. Reactions of metals. What would that come under? That's a half equation. It's somewhere here. Here we go. Reactions of metals and acids. Anyone got the answer yet? No? Metal plus acid forms metal salt plus hydrogen. So this is the salt, metal salt. So the other product is hydrogen. So just how any unreacted ion can be separated from the mixture. What do you guys think? So imagine you've got a solution of acid, you add iron to it, but not all the ions dissolved. You've got extra iron pieces in there in the solution. My session is going to end in 8 minutes. Okay, let me work quickly. So you've got pieces of solid in the solution. You want to separate them. Separation technique, you'll use filtration. Yep, well done. Filtration. Okay, calculation here, mole calculation. So remember the steps for mole calculations. We went through this in all our classes. Step 1 is to identify the known and the unknown. There we go. Step 1, find the moles of the known substance. So what is known here? We've got given 0.12 moles of magnesium. So that's the known. Unknown is what we're trying to find out. Mass of iron, that's unknown. Okay, step 1, find the moles of the known substance. So what you want to do is moles is equal to mass over mR. The mass we've got is 0.12. Divide that by the mR of magnesium is 24. So 0.12 over 24, that gives you roughly 0. I think it's exactly actually 0.005 moles. Second step, you want to do the ratio step the ratio of the known to the unknown, K to U. So that's basically ratio of magnesium to iron. The ratio is, if you look at the big numbers, 3 to 2 here. So that's a 3, that's a 2. So if the magnesium is 0.005 moles and it's a 3 to 2 ratio, how do we work out the moles of iron? This is quite a difficult one because usually it's 2 to 1 or 1 to 2. If it's 2 to 1, you halve it. If it's 1 to 2, you double it. This is 3 to 2. So what you need to do is you need to divide by 3 times by 2 to get that ratio. Divide by 3 times by 2. When you do that, can anyone work that out? I don't have a calculator. I think it's 0.003. Yeah, I think it's that. Yeah, thank you, Mahania. So that's the moles that we've got there, 0.003 recurring. And then third step is multiply by its MR of the unknown. So the unknown here is iron. So you do 0.0033 times by 56. Thank you, Georgie. Answer when you do that is, I think it's 0.1866 roughly. This is grams though. So this would only get you 4 marks. This is meant to be 5 marks here. So that means the extra mark is to convert it into milligrams. So to convert that into milligrams, you want to times it by 1,000. And that gives you 0.1866. But, yeah. Sorry. That gives you 187 milligrams. How much time do I have left? 4 minutes. Okay, that should be enough. Yep, answer is 186 milligrams. 187. I think you got to round it up if you use the full numbers because it's 66. So it'll be rounded up to 187. Okay, last question. Explain which species is reduced, which one's oxidized. Let me try and do this as quick as possible. So notes-wise, this comes under oxidation and reduction. What you want to do is work out the ionic equation of this. So magnesium plus FeCl3. Let's break that up into its ions. Fe3 plus. Chlorine is Cl minus. Yeah, because that's ionic, we're breaking it up into its ions. That's how you figure out whether something's been oxidized or reduced. Then we got Fe on its own here. We're going to keep that as Fe plus magnesium is group 2. So we're going to write it as Mg2 plus chlorine, which is Cl minus. You should include the half equation. So here on my website, guys, I've got exactly how you can write half equations. So follow these steps. So after you can go and practice this if you're struggling with it, try some of these questions out. So what's being oxidized, what's being reduced? So you can see here the Fe3 plus is turning into Fe. So iron 3 plus is turning into Fe. In these ones, the electrons need to be on the left-hand side. They need to be on the left-hand side because this is a reduction reaction. Reduction is the gain of electrons. So to get from Fe3 plus to Fe, you want to add 3 electrons. That's the half equation. That's reduction because it's gaining electrons. So what's being oxidized is magnesium. So the question is not asking this, but magnesium is going to Mg2 plus to get from Mg to Mg2 plus, you have to lose 2 electrons. That is reduction. So the answer, to get 3 marks here, you write the half equation and you say Fe3 plus is being reduced as it is gaining electrons.